Long before the mighty dinosaurs roamed the Earth, our planet was a very different place. To understand what the world was like before these iconic reptiles appeared, we must journey back in time, over 250 million years ago, into an era known as the Paleozoic. Our story begins in the Cambrian period, around 541 million years ago, a time often called the Cambrian Explosion. During this period, life on Earth underwent a dramatic increase in diversity. The oceans teemed with strange and wonderful creatures, many of which were the ancestors of today's animals. Let's travel back in time to the Archean Eon, a period that began about 4 billion years ago and spanned roughly 1.5 billion years. This era followed the Late Heavy Bombardment, a chaotic time when Earth was bombarded by massive amounts of space debris. These collisions shattered the planet's newly formed basaltic crust, exposing molten magma and leaving the surface scarred and volatile. After enduring this cosmic attack, Earth gradually cooled, forming its first stable outer layer, known as the lithosphere. Approximately 1 billion years into the Archean Eon, the first signs of life began to appear. This ancient Earth was a vastly different world from the one we know today. The surface was relatively smooth, as the tectonic activity that drives mountain formation had not yet begun. The crust was predominantly basaltic, a dark, dense rock formed from the cooling of magma. The atmosphere lacked oxygen, a crucial element for modern life, and was instead thick with water vapor, carbon dioxide, and a variety of other gases, including sulfur and phosphorus compounds. The sun's output was about 30% less than it is today, casting a dim light over the planet. The moon, much closer to Earth than it is now, influenced the planet's rotation, resulting in shorter days of about 10 hours and causing massive tidal waves. As Earth's surface cooled, water vapor condensed into torrential rains, filling the planet's low-lying regions with hot, acidic, and saline waters, conditions reminiscent of today's geysers. Despite these harsh environments, the first primitive life forms began to emerge. These early organisms were anaerobic, thriving in the absence of oxygen. They formed thin, slimy biofilms on the seabed, primarily in shallow, warm coastal areas. Due to the dense atmosphere, sunlight could penetrate only to a depth of about 20 meters, limiting the biosphere to this narrow zone. Underwater volcanic activity provided a haven for chemotrophic bacteria, which obtained energy not from sunlight, but from chemical reactions involving sulfur and iron compounds. As the planet continued to cool, sea levels rose and the atmosphere gradually thinned, allowing more sunlight to reach the surface. This change expanded the habitable zone, enabling life to proliferate along coastlines and around underwater volcanic vents. However, the land, rivers, and open ocean remained largely devoid of life. One of the earliest visible signs of life from this period was the formation of stromatolites, layered sedimentary structures created by microbial mats of cyanobacteria. These simple life forms played a crucial role in shaping the Earth's atmosphere and biosphere. However, the evolution of life was slow, partly due to the scarcity of nutrients. At this time, scavengers, which feed on dead organic matter, had not yet evolved, leading to the accumulation of dead organisms on the ocean floor. Over millions of years, these organic deposits transformed into what we now recognize as oil reserves, a vital resource for modern civilization. This period in Earth's history laid the foundational conditions for the eventual emergence of more complex life forms. The Archean Eon, with its alien landscapes and primitive ecosystems, represents a crucial chapter in the story of our planet, offering invaluable insights into the origins of life and the early development of Earth's environment. Around 3.5 billion years ago, a remarkable evolutionary breakthrough occurred. Some bacteria developed the ability to perform oxygen-producing photosynthesis. This innovation set the stage for a transformative event known as the Great Oxygenation Event, GOE, which occurred about 2.4 billion years ago. The GOE marked the transition from the Archean to the Proterozoic Eon, fundamentally altering the course of life on Earth. Before the GOE, Earth's atmosphere was virtually devoid of oxygen, and life was dominated by anaerobic organisms, those that did not require oxygen to survive. The advent of oxygen-producing photosynthesis by cyanobacteria gradually increased atmospheric oxygen levels. While this paved the way for more complex life forms, it also triggered what is sometimes called the oxygen catastrophe. The surge in oxygen proved lethal to many anaerobic species, leading to a mass extinction event that wiped out a significant portion of Earth's early life forms. The influx of oxygen also had profound climatic effects, leading to the Huronian glaciation, the longest and most severe ice age in Earth's history. This glaciation lasted from approximately 2.4 to 2.1 billion years ago, saw ice caps extend as far as the equator, turning Earth into a frozen snowball. It took the planet another billion years to transition from a world of molten lava to one encased in ice. Despite these harsh conditions, life persevered. The Proterozoic eon, spanning from about 2.5 billion to 541 million years ago, witnessed slow but steady evolutionary progress. During this time, life remained primarily in the equatorial coastal regions, where conditions were less extreme. Meanwhile, the land itself was undergoing significant geological changes, with the formation of mineral ores and new rock types. As we move forward to the Phanerozoic eon, which began around 541 million years ago, life on Earth began to flourish in remarkable ways. This eon is characterized by dramatic periods of rapid evolution and mass extinctions. At the dawn of the Paleozoic era, a massive supercontinent known as Gondwana dominated the southern hemisphere, while smaller continents and numerous islands dotted the rest of the globe. The Paleozoic era saw the emergence of a diverse array of life forms, from the first fish and land plants to the early amphibians and insects. The breakup of supercontinents and the movement of tectonic plates created varied habitats and climatic conditions, driving evolutionary innovation. Each subsequent era within the Phanerozoic eon brought new life forms and ecosystems, shaping the rich tapestry of life that we observe today. The journey from the Archean eon to the present day is a testament to the resilience and adaptability of life on Earth. From the oxygen-producing bacteria that sparked a global transformation to the complex organisms that inhabit our planet now, the story of life is one of continuous change and enduring survival against all odds. Moreover, life on land was initially sparse, limited to simple mosses and lichens clinging to rocky surfaces in a few scattered areas. It wasn't until the Silurian period, starting around 444 million years ago, that plants began to make a significant impact on terrestrial landscapes. These early land plants, primarily found in tropical regions, were simple and low-growing, but their presence marked a crucial step in Earth's ecological evolution. The Silurian period also saw a flourishing of marine life, though most organisms remained near coastlines where sunlight could reach, limiting oceanic life to depths of around 50 meters. The proliferation of plants on land during this period set the stage for more complex ecosystems. The Carboniferous period, spanning from 358 to 299 million years ago, was a time of dramatic change and growth in Earth's flora and fauna. Tropical regions were blanketed with vast forests of towering tree ferns, club mosses, and horsetails. These lush forests played a crucial role in shaping the planet's climate and atmosphere. When these plants died, they did not decompose as modern plants do. Instead, they accumulated in thick layers, eventually transforming into the extensive coal deposits that fueled the Industrial Revolution millions of years later. The Carboniferous period also witnessed significant diversification of life. The first true amphibians ventured from water to land, evolving from fish that had developed rudimentary lungs and limbs. These early amphibians paved the way for the future colonization of land by vertebrates. The Permian period, lasting from 299 to 252 million years ago, saw further expansion and adaptation of life on land. Amphibians continued to evolve and spread, while plants extended their range into subtropical regions, diversifying into various forms, including early conifers and seed ferns. This period also marked the rise of the first reptiles, which were better adapted to life on land than their amphibian predecessors. However, the Permian period ended with the largest mass extinction event in Earth's history, known as the Permian-Triassic extinction event. Up to 96% of marine species and 73% of terrestrial species perished. The exact cause of this catastrophic event remains a topic of scientific debate, with theories ranging from massive volcanic eruptions to asteroid impacts and dramatic climate changes. This mass extinction reshaped the course of life on Earth, paving the way for the rise of dinosaurs and mammals in subsequent eras. Despite the devastation, the resilience of life ensured that new forms and ecosystems would eventually emerge from the ashes, continuing the dynamic and ever-evolving story of our planet. The subsequent Mesozoic era, spanning from 252 to 66 million years ago, ushered in a period of profound transformation. During this era, forests expanded into temperate latitudes for the first time, creating diverse habitats for a variety of life forms. Simultaneously, blue-green algae began to thrive in the oceans, performing photosynthesis and contributing to the oxygenation of the world's seas. This era is perhaps best known for the dominance of dinosaurs, a group of reptiles that diversified into a myriad of species, from the towering Brachiosaurus to the fearsome Tyrannosaurus rex. The Mesozoic era also marked the rise of flowering plants, or angiosperms, which began to spread across the globe. These plants revolutionized ecosystems by providing new food sources and habitats, leading to increased biodiversity. The proliferation of flowering plants and the coevolution of pollinating insects set the stage for complex ecological interactions that continue to this day. However, the Mesozoic era ended with a dramatic mass extinction event around 66 million years ago. This cataclysmic event, believed to have been caused by a massive meteor impact, led to the extinction of the dinosaurs and many other species. The aftermath of this extinction opened up ecological niches, allowing mammals to rise and diversify. In the wake of the dinosaurs' extinction, mammals began to evolve into a wide variety of forms. This diversification eventually led to the emergence of primates and, much later, Homo sapiens. Humans are unique in their ability to not only adapt to their environment, but also transform it. Over time, humans have harnessed Earth's resources, such as coal and oil, fueling technological advancements and shaping the world in unprecedented ways. Today, we inhabit a planet shaped by billions of years of geological and biological processes, from the earliest simple life forms to the complex ecosystems we see now. Our understanding of these processes has grown, highlighting the delicate balance that sustains life on Earth. As we continue to explore and learn about our world, we bear the responsibility of stewarding it wisely. It is crucial to preserve the intricate web of life and ensure the planet remains hospitable for future generations. As we move forward to the Ordovician and Silurian periods, the first plants began colonizing land, transforming the barren landscapes into green habitats. This gradual greening of the Earth laid the groundwork for future ecosystems, providing food and shelter for emerging life forms. The Devonian period, often called the Age of Fishes, saw a remarkable proliferation of marine life. It was during this time that fish evolved jaws, a crucial adaptation that allowed them to diversify and dominate the seas. Some species began to explore the land, leading to the first amphibians. The Carboniferous period is famous for its extensive forests of giant ferns, horsetails, and club mosses. These lush forests created vast coal deposits, which we rely on today as fossil fuels. The dense vegetation also supported a diverse array of insects, including dragonflies with wingspans of over 2 feet. As we approach the end of the Paleozoic era, we enter the Permian period. This time was characterized by diverse ecosystems, including early reptiles, synapsids, mammal-like reptiles, and large herbivorous and carnivorous species. The most notable were the Dimetrodon, a predator often mistaken for a dinosaur. The story of pre-dinosaur Earth culminates in one of the most catastrophic events in our planet's history, the Permian-Triassic extinction, also known as the Great Dying. Around 252 million years ago, a massive extinction event wiped out approximately 90% of marine species and 70% of terrestrial species. The causes are still debated, but factors like volcanic activity, climate change, and ocean acidification likely played roles. In the aftermath of the Great Dying, life on Earth gradually recovered, setting the stage for the rise of dinosaurs. The Triassic period, which followed the Permian, saw the first true dinosaurs evolve, along with early mammals and the first turtles. This new era marked the beginning of a 165 million year reign of dinosaurs, shaping the future of life on Earth. The story of life on Earth before the age of dinosaurs is a testament to the planet's dynamic history and the resilience of life. From the Cambrian explosion to the Great Dying, each chapter reveals the intricate and interconnected nature of our world. As we continue to study these ancient eras, we gain valuable insights into the past, present, and future of our existence.